Okay, welcome back. We got another video here. This is going to be using what I call the elimination method. Elimination method. This is yet another method for solving a system of equations. And this works particularly good for linear equations. In fact, this is my favorite method. I really like it. Okay? Especially for certain systems. So once again, just a quick reminder, when we're solving a system equation, we're trying to find the x and y, or numbers I can replace x and y with that'll make both equations true. So this method actually relies heavily on the addition property of equality, the thing that says you can add the same thing to both sides of the equation, and the equation remains equivalent. So what I'm going to do, and this one really shines when you have a situation like this. This is set up perfectly for the elimination method. Notice that in the first equation, I have a 2y, and in the second equation, I have a negative 2y. The reason why that's so cool is because if I was to add these two equations together, the y's would be eliminated. That's why it's called the elimination method, right? Because if I add 2y to negative 2y, I get 0. Okay? So check this out. If I add 3x plus 4x, that's 7x. Add 2y to negative 2y, that's 0. And add 5 to 2, that's 7. Now, why can I do that? Well, because I know it doesn't look like it, but I'm adding the same thing to both sides of the equation, because this right here says that 4x minus 2y is equal to 2. So if I add 2 to this side of that equation and 4x minus 2y to that side of the equation, I'm actually adding the same thing to both sides of the equation because they're equal to each other. Isn't that a nifty little deal? And again, the reason why I'm doing this is because it eliminates one of the variables, and I'm left with just one variable to solve, and actually a very simple equation to solve. I just divide both sides by 7. I get x equals 1. Notice in substitution, we kind of did a similar thing. We use substitution to get the equation down to one variable, right? Right here. Okay, so, but we're not doing that right now. We're doing the elimination method. And so then, of course, I still have to find the other one. So I'd have to go back up to one of these equations. Doesn't matter which one. And I could do like 3 times 1 plus 2y equals 5, which means 2y is equal to 2, which means y is equal to 1. So my solution would be 1, 1. Okay? So what if I had 3x plus 2y equals 5 and 4x minus 2y is equal to, no, I'm sorry, plus 2y. Let's change this. 3x plus 2y is equal to 8 and is 10, right? So in this case, if I add them together right now, I would get 7x plus 4y equals 18. And it didn't do me a bit of good because I still have an x and y in my equation. So I still can use the elimination method, though, because what I'm going to do is I'm going to change these two equations. I'm going to leave 3x plus 2y equals 8 alone. But I'm going to change this equation so that it has a negative 2y. And I can do that by multiplying both sides by a negative 1. So negative 1 times 4x is a negative 4x. Negative 1 times 2y is a negative 2y. And negative 1 times 10 is a negative 10. Add them together and I get negative x. 0, that's what I was going for. And what do I get there? Negative 2. So then I divide both sides by negative 1 and I get x is equal to 2. Isn't that nifty? So then I go back to one of these other equations, like maybe this one, and I do 3 times 2 plus 2y is equal to 8. Well, that's 6 plus 2y is equal to 8, which means 2y is equal to 2, and y is equal to 1. So my solution would be 2, 1. Isn't that fun? All right, let's try another one. What if I have like 3x plus 2y is equal to 7 and 4x plus 3y is equal to, let's see, 10. Now notice that there's not a simple fix here. If once again, if I add them together right now, I would get 7x plus 5y equals 17. That doesn't do me a bit of good. So I don't want to do that. I'm going to rewrite them. So what I'm trying to do is get them to match up or to be the opposite of each other. So for example, I'm looking at 3 and 4. What if I multiplied the 3 by 4? But what if I multiply this one by 4 and multiply this one by negative 3? See what happens. So 4 times 3 is 12x. 4 times 2y is, man, oh man. Plus 8y. And of course, 4 times 7 is 28. Multiply negative 3 times 4x, that'd be negative 12x, and see that it achieved what I was looking for. Yay! Negative 3 times negative 3y is negative 9y, and negative 3 times 10 is negative 30. Now they're ready to be added together. 12x plus negative 12x is 0. 8y plus negative 9y is negative 1y. And 28 plus negative 30 is negative 2, which means y is equal to 2. And then once again, I go back over here and think, okay, pick any one of these equations. Like, for example, 3x plus 2 times 2, because it says y is 2, is equal to 7. That means 3x plus 4 is equal to 7, which means 3x is equal to 3, and x is equal to 1. So my solution again is going to be 1, 2. So that's the elimination method. And again, the reason why I can get away with this, just to remind you, is because all I'm doing is multiplying both sides of the equation by 4 here and both sides of the equation by negative 3 there. So that is totally legal in the realm of mathematics. So there's 3 different techniques. When you come to a system of equations, you should come to it with those 3 techniques in your head. And you're looking at the particular system of equations thinking, well, which one of these is going to work best here? Now, some people just like one method a lot better than the other, so they just kind of use that almost all the time. But every once in a while, it is good to pay attention and look at which ones are actually because sometimes substitution is going to work nicer, sometimes elimination is going to work nicer, and sometimes graphing works okay. So there you have it. I posted some worksheet that has a bunch of system equations on it, and I will make a video working through those worksheets just to give you some more examples. All right, have fun.